Hello and welcome to the channel where we prepare Cambridge Advanced Level Mathematics students for their examinations by assisting them to practice past examination questions from past papers from previous years. The syllabus that we follow here is syllabus 9709, Pure Mathematics. And in today's lessons, we brought you paper 2 from year 2020, question number 6, which reads as follows. I've actually got the question on the board up there. The parametric equations of a curve are x is equal to e to the power 2t, y is equal to 4t e to the power t. The first question is, show that dy dx is equal to 2 brackets t plus 1 all divided by e to the power t. Second question, find the equation of the normal to the curve at the point where t is equal to 0. I've put some little numbers in red brackets there. Those represent the marks allocated to each part of the question by the examiner. Now, if we had been given the equation of this curve in the form y is equal to 3x to the power 5 minus 4x squared plus 10, finding the y dx would have been a straightforward exercise. Dy dx is equal to power rule there, 15x to the power 4 minus 8x. That would be dy dx. This is because the function here is given directly as a function of x. Y is expressed directly as a function of x. In this example, there is no explicit relationship between y and x. Y and x are related through the parameter t. Of course, in some cases, it is possible to eliminate the parameter t and recover your explicit relationship, or it might not be explicit, but a direct relationship between y and x, from which you can then go straight to find your dy dx. But in this particular example, if we try to eliminate t, we can end up in a ditch, because look, here you're going to end up with an ln x and ln y there, and we are in more trouble than what we are looking at right now. And so we have to proceed in another direction. What do we have to do? Okay, the first thing that we do here is to find, first of all, the rate at which x varies with t, in other words, dx dt, and the rate at which y varies with t, in other words, dx dy dt. So first of all, we must get our dx dt. Then we get our dy dt. Then we combine these two results together to give us our dy dx, which is equal to dy dt divided by dt dx. This we can call the parametric differentiation formula. This is the formula that we can use to find the dy dx when y and x are expressed in parametric form. Dy dx is given by that. Now let's see how this helps us in our present predicament. Allow me to draw a line here. I want to create some space. So okay, there's new space there. So what is dx dt? Well, dx dt is equal to 2e to the power t. 2e to the power 2t. What is dy dt? Well, in dy dt, it looks like we have one function multiplying another function. In other words, maybe we can call this function here our u, and this function here our v. So u times v. Y is equal to u times v. What do we have to do here? We have to resort to the product rule. And just to help those who have forgotten, the product rule works like this. If you want to find d dt of uv, the derivative is v du dt plus u dv dt. Now, in our example here, we called this one u and we call that one v. So this will give us v is equal to e to the power t. We put it in brackets. What about du dt? Du dt is just 4 because u is equal to 4t. Then plus here, what is u? U, of course, is our 4t in brackets. What is dv dt? dv dt is simply e to the power t. We can simplify this to 4e to the power t plus 4t e to the power t, which we can factorize to 4e to the power t, brackets, it goes here once, it goes here t times. That is your dy dt. Okay? So, but we are, so let's put it here. Our dy dt is equal to 4e to the power t, brackets 1 plus t. We are, of course, interested in dy dt. So we now resort to our parametric differentiation formula, dy dt, dy dx now. Let's just clear some space here. Our dy dx then is given by dy dx is equal to dy dt, which is 4e to the power t, brackets 1 plus t, divided by dx dt, which is equal to 2e to the power t. And we can cancel things here, that's 2 there. E to the power t divided by e to the power 2t is just 1 over e to the power t. So we are left here with 2 brackets 1 plus t e to the power t. And that, of course, is the result the examiner was asking us to show, dy dx. Now the next question says, find the equation of the normal to the curve at the point where t is equal to 0. I want us to draw a nice little picture here to indicate exactly what is going on at this point where t is equal to 0. And then from there, we will be able to know in which direction we should proceed. Now, suppose we have our curve in this form. And this, of course, is expressed in parametric form. X of t is equal to e to the power 2t. Y of t is equal to 4t e to the power t. And suppose also that this is our point where t is equal to 0, because we are supposed to find the normal to the curve where this t is equal to 0. But first of all, let's understand what this means. This is the derived function of the curve. And at any point along the curve, the value of the tangent at that point is given by the value of t at that point, at the value of dy dx at that value of t. Let me repeat myself here. This is the derived function of the curve. And the value of the derived function at any point along the curve will be equal to the gradient of the tangent at that point. For example, we have our point t here is equal to 0. So the tangent at this point, let me draw it in red. Let me draw a tangent at this point to represent the tangent at the point T, and I will call this tangent T. So the tangent at point T is equal to 0 here. Let's not forget our value of T. T is equal to 0. At this point, T is equal to 0 has got a value given by when T is equal to 0 there. So therefore, we can say, what is dy dx when T is equal to 0? dy dx at T is equal to 0 will be given by 2 brackets 0 plus 1 divided by e to the power 0 is 1. So therefore, the value is 2. So the gradient at the point where T is equal to 0 along this curve has a value T. But we are not interested in the gradient in the tangent here. What we want to calculate is the equation of the normal. What is the normal to the curve? The normal to this curve is a line which is exactly at right angles to the tangent at this very point. In other words, it's a line which is at 90 degrees to the tangent at this point. This is the relationship of the two lines. Let's label this new line of ours N for normal. Okay, now what do we know about the two lines which are at right angles to each other? Well, if the gradient of one line is known to be, let's say, M1. Let's say gradient of this line is M1. Then the gradient of the other line, which is perpendicular to it, must have gradient minus 1 over M1. In other words, the gradient of the other line is minus the reciprocal of the gradient of this other line. So now we have calculated the gradient of the tangent to the curve at T is equal to 0, and we found 2. So what will be the gradient of the normal at the same point? It must have gradient minus 1 over 2. So we can actually conclude that gradient at T is equal to 0 of the normal is equal to minus 1 over 2, since the gradient of the tangent is 2. Now we know one bit of information about our normal. It is gradient minus 1 over 2. That's its gradient. But we need a second piece of information before we can be able to calculate that equation. Where does this normal pass through? Well, we know a point it passes through. It passes through this point where T is equal to 0. So what are the coordinates of this point? The coordinates of this point are given by x0 and y0. In other words, the value of x when T is 0 and the value of y when T is equal to 0. So let's calculate that. That gives us x of 0 is equal to e to the power 0, which is 1. Y of 0 is equal to 4 times 0, which is 0 times 0, which is just 0. So this point here is coordinates 1, 0, meaning x is 1, y is equal to 0. So what is the equation of the line? Now we are in business, because we can now say y minus 0, that is 0 there, divided by x minus 1 is equal to what? Is equal to this gradient, which is minus 1 over 2. Cross multiplying, we get y is equal to 2y is equal to minus x plus 1. Dividing right through by 2, we get y is equal to minus half x plus a half. That's the equation of the normal to the curve at the point T is equal to 0.